Welcome to the day one training session of first module of CNC, and the first module will be having introduction about the complete CNC machine. Dr. Saad Pravesh will be taking over the session, and he'll be introducing you the 5-axis CNC setup what we have in our NIT Srinagar. Over to you, sir.
Thank you so much, Dr. Nish. I hope I'm audible. Hello. Thank you so much, Dr. Nish. I hope I'm audible for everyone. So this is the workshop area where this machine was installed in the commission. So this is the DMT. It's a German company which has sunlight machine work. Then the installation and commissioning was over in 2021 March. And now it's fully commissioned, it's running. First of all, I'll introduce you to the operator. This is engineer Nadeem. He's an engineer by profession. He has joined us for the last 1 year. So he has got the training from Bangalore and the Delhi units of DMG Mori. So, but he's trying to gain more and more experience, and then we are looking for him to be the pilot of this aircraft, of this machine. And I'm sure that the most complex jobs which will come to us, we will be able to program and produce it to the accuracy desired. So let me start with now the first important thing which we learn in the morning is the safety issues. So it's very, very important for us to understand how to run the machine safely, how exactly the people around are working safe in a safe working environment. Well, this is the main unit. If you can see, GMU 50. This is the silos which we're talking about, and then the other parts are the UPS, the compressor, this is the chiller unit, and the programming is done here on this PC. So now I would hand over to the main operator, the technician, the engineer of this machine, who is trying to make everything possible here. First of all, before I hand over, some important parts, very complex shapes which were produced in this machine. Look at the shape, the complexity, the contours, the angles, the holes, and of this job which by producing a replica of this part. So this part was manufactured at Germany in the DMG unit, and then this machine was installed. All its axes and other accuracies were checked by reproducing this part and then measuring its dimensions, and it was found that this has been done. The machine has been commissioned and installed to the best of its accuracy. These are some of the parts which are produced by so it has a lot of hydraulic and pneumatic systems, which Mr. Nadeem will demonstrate you. Lot of fluid systems are used by the machine. There are chips which are generated. All the chips are collected in the chip collecting unit. The oil, the fluids are recycled in this filtration unit, and then the oil, the filtered oil is fed back to the machine. So let me hand over you to Engineer Nadeem Mistry, who will take you forward in the journey of this machine. Mr. Nadeem. एक मिनट आप ये देखना पड़ेगा ना आपको ये
working as CNC operator here. You can put out the machine and some of the parts of the machine. So, this is CNC module. CNC module can unit. So first we'll have a look to some of the parts of the machine. Uh, so here you can see this is the UPS that provides the power backup to the machine, which supplies the constant power to the machine as well as provides the backup for around half an hour to the machine. So this is a three-phase supply, power supply to the machine. So this is the part that we have a whole part here. Uh, that is covered around compressor. So this is the air compressor. But that is supplies the air that is supplying to the machine. So here the range for the compressor is between 8 to 9 knots. So the maximum land mass pressure is attaining here and the minimum of 8 bar pressure the minimum range of this compressor. So this is the 25 compressor that supplies the compressor here to the machine side on different so also then have a whole part that for the chiller unit. So this part this is actually refrigeration part, or I can say the refrigeration process is done by this chiller unit. Uh, the different core components are actually four different core components is provided by this chiller unit. Actually, we use the cooling here. The cooling is the temperature of the cooling is lower here, and then it is applied to the core components like cable bearing, spindle bearing, and guide also. So the capacity for this chiller unit is around 35 liters. Uh, and we'll have and look through some of the internal components of the part of the machine. So here you can see we have got some small tanks here. So this is a cable using purification tank. So some white music here. So this provides this white is continuously supplied to the single bearing and cable bearing. So this is the bearing purification tank. So once the minimum level, you can see the maximum and the minimum level. Once the minimum level is then we have to indicate. Then also we have another tank here, which is tank of purification. So we are using this here. And you know, so this is for active purification. But again, let's see what one is. So this is for purification of the light waves. Then we have here this filter unit. So we have here this filter unit as well. As is used to filter this lubricant. that is used to filter the lubricant coming out of the machine, coming from the tank, and that is supplied to the bearing. So here, so this is actually the oil care lubrication for the bearings, wheel bearings, motor bearings, cable bearings as well. Then also we have here this filter unit. So the air compressed air that is supplied to the machine is filtered, is also filtered here. The compressor air is filtered at the exit of the air compressor as well as the input of the machine. Then it is supplied to different parts of the machine. Also, we have here this hydraulic pipe that is used for clamp and unclamp of the tool. That is done while doing performance. So here, so this hydraulic pipe is changed periodically. Uh, and also we have here this data button and for the basic system sliding the user sliding side of the machine for the patient before different tools. Uh, and we also have got some pressure gauges here. So here you can see the air supply to different parts needs to be checked whether the air pressure is within the range or so you can see here the pressure takes scale for different components. So it should be within the range of 3 and here we will do this is for the fluctuant air pressure that means the coolant is used coolant is used that needs to be some cleaning. So the compressed air is for
Sir,
the
the voice is
cleaning.
not clear. Hello? The voice is not clear.
Okay, I'm trying to phone off first.
Nadim, you have been muted actually. You can just hold it. Nadim, you have been muted. Nadim, you are muted, yeah. Now it is
Am I
fine.
audible? Audible
Yeah,
now?
now we are audible. Yeah, now we are audible, yeah.
Okay, fine. So I think I have completed
Now we are
this.
clear. Just go with this flow. Hold this so that it will be very clear. Yeah, now it is clear.
Okay, fine, sir. I will
Okay.
just give a short overview again. So this is the lubrication spindle bearing lubrication tank where the oil is supplied to the machine. Bearing, the spindle bearings, the motor bearings, as well as the cable bearings. So here you can see the minimum and the maximum values of the oil. So once the minimum value is reached, we need to reduce this lubricant, this oil again. Also, we have some rings here, ring type here. So this provides the axis lubrication for different axes like we have X, Y, and Z axis. So this lubrication is provided to these axes. Also, we have this filter unit here. So the oil that is supplied to the bearings from this tank is first filtered here, and then it's mixed with some air. So actually, it's a air oil mixture, or I can say air oil lubrication that is provided to the bearing. Also, the compressed air that is supplied to the machine is also filtered from this unit. Then we have this hydraulic oil tank here. So this is utilized for clamp and unclamp of tools that are being utilized while in performing different operations. So we need to periodically change hydraulic oil. So then we have some other filter units here. So this filter unit is for loom and loom is actually a maintenance system by which we measure different tools, the length of the tools as well as the diameter. So this is also a filter unit for that maintenance system. Uh, now I think done for this unit part. Now I'll go to the other part. We have also some here special case here on a bus. So we need to keep checking what is the pressure that is applied to the machine is within the range or not. So here it is mentioned that we want to be sure for
Nadim, hold the mic properly. Your voice is not audible. Start. Yeah. Now it is clear. Yeah, now it is clear.
ये देखो श्योर का कुछ नहीं हुई so this is the on off button on off switch for the machine and here we can also see that it is written here that the maximum rpm of the machine is 15,000 rpm of the spindle and also we have given other information like the serial number and the model of the machine here so now we move to another part of the machine. So we have one more part called as band pass filter. So while we remove material from the workpiece, we utilize some coolant here between the interface of the workpiece and the tool. So that coolant is continuously supplied while we perform machining operation. So this part is our band pass filter. This part actually filters the coolant that is being utilized while machining. So actually the coolant is fed into this band pass filter and it is filtered here and then supplied back to machine so that we can reuse it again and again. So this is our band pass filter system here. Then we have one more part here that is called conveyor. So this part is the conveyor that transports the material that is removed in the form of chips to the connector. So the chips are transported by this conveyor to the collector. So here you can see this is our collector. So the material that is being removed while we have machining different operations is collected here. As you can see, the wasted material, I can say in the form of chips, is collected in the collector. So this was just an overview about some of the parts of the machine. Now we'll see the main part, the machine, the specifications about the machine, the different axes about the machine. So this is our DMG Mori DMU50. DMG Mori is actually the brand name, and DMU50 is the model of the machine. So here 50 implies the maximum stroke of the machine. So what does the maximum stroke means? It says that our maximum movement of the axis is 50 centimeters, or I can say 500 mm. So here this 500 mm movement or travel is in x-axis direction. So the maximum length of the workpiece can be 500 mm that can be machined on this machine. Now we'll see some. So this is actually a 5-axis machine. So it means that we have got 5 axes here. So I'll first run a short program, short cycle, so that you will be able to analyze. The different axes, the different 5 axes. Then I will explain them a bit deeply. So first I am going to run a short program that will demonstrate you the movement of different axes. Compressor. So I'm going to run a short program. So we'll be running this warm-up cycle here. So this program is manually. Okay, I'm going to first I'll just give the introduction about this program. Actually, a program is made of blocks, and the blocks are made from different codes or some special commands as well. So we'll be getting a bit deeper later, but this time I'm just going to run this program. Actually, here you can see the pneumatic pressure is low. So once the pressure is in between the range, then we'll start the cycle. Till then, we'll have a look. We'll have a look to the other uh, area, or I can say the other section of the machine. And this is our the tool magazine area where we load our different types of tools. So here we have got a tool magazine having 30 pockets. Means that we can mount 30 pockets at a time on this tool magazine. So I'll be showing you the different tools that are loaded on the machine. So you can see here, we have loaded some of the tools here. Uh, so we can load up to 30 tools on this tool magazine. So you can see here we have got 30 pockets. So we can load a maximum diameter of the tool around 130 mm diameter tool can be a maximum of 130 mm diameter tool can be loaded on this single pocket on at one location, and the maximum weight the tool can be 8 kg, and at maximum we can load up to 30 tools at a time. So here we have loaded some of the tools. I'll just then go through about some of the tools here. So this is our drilling tool. So this is our drilling tool, and we are using here the HSK A63 HSK A63 folder here, and we have used it. They call it identified for this particular drill bit having size of around the strength size I can say is around 10 mm. So we will be loading these tools later, and I will show how we load this first. We need to put the information regarding these tools onto the machine, onto the interface of the machine. Then we have to load it here. So we have got different tools here. So this is a different type of tool. It's a hand mill tool. So this tool can remove the material at the end as well as at the periphery of the tool. So this is a solid carbide hand mill. Then we have here other tools like we have another tool as this is called a hand mill cutter. So actually this is a inserted tool. So we have used inserts on the periphery with the help of, we have mounted these inserts with the help of screws here. So this is hand mill cutter. So these inserts, once the inserts are utilized or are wear some wear, once they are wear or they are utilized, then we can change these inserts, and we don't need to change this holder. We can again we can again mount these inserts onto the holder with the help of screws. Then we have another tool that is called tapping tool. So this is actually M12 tab that is used for tabbing operation. So we can directly we first bring the hose of desired size and then just can perform this tabbing operation as per the requirement. So this is our tabbing tool and 5 LF. Now, am I audible? So, we'll first see the different axes. So this is a 5 axis machine. We'll be seeing the different axes. So I'll be first running the short program that will demonstrate the movement for different axes. So I'll be running this short program. It will just demonstrate you the different axes, the movements for different axes. So we'll be executing this program. So you can see here. Am I audible? Hello? Am I audible?
Yes, sir. It's okay. It's okay.
Okay, fine, sir. So I have just started a cycle here. So you just first analyze what are the moments here. Actually, we have here 5 axis moment. So you will first analyze it, then explain it more deeper. Okay, first we are actually cranking a tool onto the spindle. Okay, so this is one of the axes, and that is called the B axis. So analyze it, how it is rotating. Okay, so there is a rotation in the clockwise and in the anti-clockwise direction. So this is one of the axes. Then you can see focus it here. Yeah. So this is one more axis called as C axis. So the table can rotate from 0 degree to 360 degrees. Like it is going in the intervals of 90 degrees. Now the spindle, now the spindle is moving. So the spindle is moving downwards. This is our Z axis movement. It will again go up. So this is the Z movement. Then this is our Y axis movement. The spindle is going away from the, I can say, away from the front window. And spindle is moving to the right. And this is our X axis movement. Okay, so it will again run. So again, this is the B axis movement. So this B axis can swivel. It can swivel between minus 35 degrees to 110 degrees angle. And our C axis can rotate from 0 degree to 360 degrees. So this is our C axis. I'll try to focus. So you just analyze these axis moments. So this is the right axis movement. Again, I'm repeating. So we can have positive y-axis movement or we can have negative y-axis movement. Then this is the y-axis movement. Then this is our x-axis movement. So this is our b-axis movement. Then this is the c-axis movement. So it can rotate in both the directions, clockwise or anti-clockwise. This time this table is rotating in the clockwise direction. Then you just analyze the movement. This is the x-axis movement to the spindle. So, and this is the y-axis movement. It is coming towards me. That is the y-axis movement. Then it will move down. That is the z-axis movement. So actually here, the three axes are provided to the spindle. The x, y, and z axis movements are provided to the spindle here, and other two axes are provided to the work table, I can say. So here, so this x-axis movement, this x-axis travel, I can say, is in between the range of 0 to 650 mm. And I also mentioned that the b-axis rotation angle is from -35. So this clockwise movement is actually the negative direction of the b-axis. And also for c-axis, it can rotate here from 0 to 360 degrees. Whether in positive direction or in negative direction. That depends as per our need. So here, this x-axis movement, the maximum travel is 650 mm for x-axis, and the maximum travel for y-axis is 520 mm from its home position. And the maximum z-axis travel is 475 mm. So that's why we call this machine as the 5-axis CNC milling machine. As you may already know that milling, we call a milling tool. The principle for milling, actually, I can say, is that our tool rotates, but our workpiece remains stationary, I can say, in general. So here we provide rotation to the tool, as well as this small rotation can also be provided to the workpiece here, because we are having here 5 axes. Normally in milling machines, in general normal milling machines, we have only got 3 axes here. Only x, y, z movements are there. And the z movement is only provided to the spindle, and the other 2 movements, x, y movements, are provided to the table. But here we are having 5 axes. Then here we have got 3 axes to the spindle only. X, Y, Z axes are given to the spindle, and the other 2 axes are given to the table. So here the maximum, or I can say the rapid feed to the machine. The rapid feed means the speed at which the spindle moves in any of the direction, that is X, Y, Z. And that feed is, the maximum feed is here as 42 meter per minute. So we have got a rapid feed of 42 meters per minute. for XYZ, and also for C and B axis, we have this rotations per minute, and for B and C axis, we have 30 rotations
तो नहीं
per
है
minute.
आपको पता ही
So I can say
कोऑर्डिनेट में
30 RPM for C and
खाता
B
देख रहा
axis.
है
So
किसे पता है कितने खाने में पता
I'll just stop the cycle now.
कितने याद है मेरे भी तो टाइम है लाइक करने का जिसका लिखना है 3% और
So here
स्टेज बच्चे
now
थे
you can see it more clearly. So this is the table. The dimensions for this table
इसमें की
are
करता है
the dimensions for this table are it is 630 in the x-axis direction, 630 mm, and in the y-axis direction it is 500 mm. But we can load, we can machine maximum length of the workspace
kurang bahan
of
satu
around 500 mm.
dua satu
So a maximum, we
akad
can say the
akad
maximum scope of the machine is 500 mm. So here, this is actually a clamping system. We call it as a vice. So it is actually clamped on this table with the help of these bolts, nut and bolts. So here you can see here that we have got some T-spots here. So these T-spots are used for these T-spots are used here to clamp our workspace directly, or we can clamp these clamping devices like this device clamp here with the help of clamp. So we have got here 7 T-spots. Also, the center distance for this spot is around 63 mm. So here now we have got here 3 axes for onto the spindle. The XY axes are onto the spindle, and the 2 axes B and C are provided to the bus table. So here this B axis, it is actually rotating about Y axis. The B axis is rotating about Y axis between a range of minus 35 to plus 110 degrees. And this C axis rotation is moving around, is moving about Z axis. Okay, if in some machines there can be one more axis as the fixed axis, and that rotates around, that rotates about x axis, but only we have only got here 5 axes presently. So apart from that, we have here some measuring system installed on the machine. So once the tool, okay. So this system is this mechanism is actually called the balloon system. So this is installed on this machine. In some machines it can be there or it cannot be. But here we have got this balloon system. So once we need to perform some operation on the machine, so first we need to measure the tool. Measuring tools by hand provides much accuracy and profile. So we have got here some measuring system that's called balloon system. So the length and the radius of the tool is measured here by utilizing laser technology. So the laser is utilized here to measure the diameter and the length of different types of tools that we load onto the tool magazine. So I will also run 2D programs. So we'll measure some tools. But first we'll load these tools and provide the scales. Then we are going to measure with the help of this balloon system. So actually the precision, the accuracy of the machine is very high on this machine because we have got a least movement to the tune of 1 micron. So actually, I'll show you.
So whatever, okay, reducing
So
it
here, first I'll just give some introduction about this interface. So
reducing it, you plan of your
this is our
everything outside.
multi-touch screen here. This is the monitor, or I can say the user interface part here. So here
Even
you
broke.
can also see we have a number of buttons and other knobs available here so that we can directly control the machine. So here you can see. So this is the main screen of. So here actually first I'll introduce the interface. So this Salos is an integrative operating interface that is provided by DMG Mori. So it provides us some human-machine interface, and that is provided by DMG Mori. And also Salos comes with Siemens or any other controlling software, I can say. So Salos comes with Siemens here. So the controlling part is provided by the Siemens. While this interface is provided by the DMG Mori, while the controlling part is provided by Siemens, that is also a German company, industrial manufacturing company. So here we have got different options, or I can say we have. First, I'm going to explain this main screen. So here you can see that this is our.
Baya sa baya. Ram.
So here you can see that we have it is shown here that we have x axis, y axis, z axis, c and d axis. So here it shows us the position that the x-axis is presently at the position of 251.903 mm. So it is from the origin point. So I'm going to manually move this axis.
That was 94. ये गोने में था ना मेरे में आप किस साइड में जाना तेरे केस में किस साइड में जाना
So there is the least movement to any axis. To any x, y, z axis, the least movement can be 1 micron. So here I'm going to move it by 1 micron. So you see here, it is x-axis is 251.903. Then I'm going to move it by 1 micron. Just a minute. Okay. Now it's the x-axis position is 252.207. So I'll be moving it by 1 micron. Okay. Now it's 208, 209, 210. So the least movement, or I can say the minimum dimension that can be provided to the machine is 1 micron. So this 1 micron movement can be provided to all the 3 axes. So for y, if I'm going to move y, I can also move it by 1 micron. Okay. Then we can also move this z-axis. Is it visible? So here you can see that a minimum of 1 micron movement is provided for all the 3 axes. So we rotate it. I can say a single degree is divided into 1,000 divisions. Like 1 mm is divided into 1,000 microns. Likewise, here a single degree is divided into 1,000 parts. So I can here provide a 1,000 part movement to the C axis or to the B axis.
लिटरेसी रेट उसे पता है
So here you can see.
24
So
2 इंच का सीमा
I have provided
किसी को रखते
1,000 movement to the C axis. So it is 0.002, 0.003, 0.004. So even for these movement to this axis. So you can see for C axis, we are providing it in the steps of 0.001. And also for B axis, we can also provide this least movements to the two different axes. So for all the axes, the least movement is divided into the 1,000
इंडिगो कलर
for C axis 1 degree divided into 1,000 parts.
दही में छिपा
So here also you can see here that we have some machine is telling us that this tool is mounted onto the spindle. What is the radius of the spindle? Tool, and what is the length of the tool that is being loaded onto the spindle. So here you can see the tool name. Likewise, the other portion is showing what is the feed that is presently onto the spindle. So this time the spindle is stopped, so there is no such feed. So you can otherwise see some value here in mm per minute. Also, the third screen shows us what is the RPM of the machine. So this time the spindle is stopped, so no such RPM is shown here. So that's why it is shown here as 0. So while we perform some operation, we need to make sure whether the input parameters that we have set in the program are we have to confirm actually are exactly the same or are say different from whatever we have inputted. So then that is the main screen where our program, once we run the program, we will see that which block is currently running or which commands are currently going to execute. So we can see. Also we have some here shortcut screens like we can directly call some tool here. We can directly provide some RPM here, and we can also perform some other functions. Like here, if I want to call some tool, I'll just select it, and say for example, we are selecting a dia 63 long edge milling cutter here. I'll click OK. Then I'll simply start a cycle. The tool which I have selected is going to get loaded onto the spindle, and I can directly unload the tool, just providing here 0 value. Okay, so we have work meter. Do you want to? Now there are other shortcut screens. We'll be discussing them while we perform some operation. So for now, I'll just introduce this measuring system, tool measuring system, and also give a short introduction about the work offset. So actually every machine every machine has a
Plus 4,990,
fixed home position, I can say. Every machine, whatsoever is the machine, it has got the home position. So here, first I'll bring XYZ to the home position. That will be better for your understanding. So I'll be moving the X. So the home position for X, Y, and Z is at
ना उसे बाकी कौन का है यही
zero
जोड़े
point 0.1 mm.
108.18
It's not exactly at zero, I can say. So I'll just like please start the cycle.
उसे क्या था ये तो पीछे कम ही है यो देखिए जो मैं देखता
So
हूँ
you can see here.
स्टैटिस्टिक्स शॉर्ट टाइम शॉर्ट टर्म
I have provided some work option here. By I'll be moving it manually, or I can move it using this MDI. We have one more option here. That's called MDI mode. I'll simply write the code.
नहीं और अच्छा कर सकता था तेरे को ब्लेंडर भी ना चाहिए कानून तो सिल्वर चलाएगा मगर मार्क इस दही अगर तो 3000 चल पड़ा इस दही मार्क
Okay, just I'm writing a code.
सर्विस पे तो ठीक है more shit show me movie machine share attempt work remember this inshallah just go and do it good
So as you can see here, so these three axes, X, Y, and Z, are moving to the home position, or I can say the origin or the reference position of the machine, and that is fixed for every machine. And we also call it as a machine forget system. So these axes are moving to the MCS, the origin, home position for these axes, and that is at 0.15 is at 0.1, and for other two axes it is the same. So you can also see here now.
ये मैजिक नहीं दिखाई आगे देखो
So यहाँ पे आप you can see here that this x1 is at minus 0.1. Y is also at minus 0.1, and Z is also at this point. So this is the home position for these three axes. Also for B and C axis, the home, I will also set the home positions for them.
Is there anything else?
Okay. Okay. Now you can see here. So this is the home system for XYZ. Okay. And this is the home system for CNC actually. So this time the CNC are at 0 degrees. Are at 0 degrees. So there is no such movement provided to the machine. Now we'll be taking some work offset. So actually, what offset implies that we have we have to machine different types of components, different types of work pieces of different dimensions. So we just set the work offset as per the dimensions of the work piece. So for example, I'll just take an example here. So here you can see this is the workpiece that we are going to machine in the coming days. So here, once this component is loaded onto the machine, so I need to provide some work offset. Means that I need to tell the machine that this is the origin point where the machine is supposed to take the moments, the measurements as programmed. So say for example, so once this component is loaded onto the machine, then I need to set the bulk offset. I need to set the origin point on to the component somewhere. I can set it at the center. I can set it at any corner or at any other location. So I'll just write onto the machine. So here, once our component is loaded onto the void, so if we have to perform some operation, so the very first thing we have to first assign the work object. So the machine for this system MCS is fixed. It is at this position, but my job dimensions can be different. So I am supposed to provide the work object onto the work piece as well. So for that, we have got some technology that's called probe. So with the help of probe, we are setting these work objects to different work pieces having different dimensions. So we'll be also doing that. But before that, we are going to run this known cycle so that we'll be able to analyze how the dimensions of the tool are measured.
ठीक मतलब special बच्चे नेट के फिट होता नेट के फिट
Okay, now we'll be running this bloom cycle for the measurement of tool length and diameter. So what we do, we first install, we first load the tool onto the tool machine. So I'll show you how. So here, so first I'm going to, this is already loaded onto the magazine. So I'm unloading this tool first. Okay. So here I have unloaded this tool. Now we are going to load it again. So this is a inserted milling cutter which has got 5 edges, one, two, three, four, 5. So while machining, we calculate the parameters like the RPM and the feed as per the dimensions of the tool. So here, first what we do before loading a tool onto the magazine, we just we just first feed the data here in the tool list. So here you can see we have got 1 to 30 pockets here. So we have all the information here. At pocket number 1, we have got boring tool. At pocket 2, we have got drilling tool, and then end mill. Then at pocket 4, we have new tool, tapping tool. So we have a complete list here. And also we have at pocket number 29, we have a master tool. Then at pocket number 30, we have this pro, that is a work offset device. It's actually a electronic device. So these are this probe is at the fixed pocket, and also this master tool is at the fixed pocket. So now we are going to load a tool. So what we are going to do, we simply highlight this row and we just write the tool name here. So I'll be keeping the same name what it was earlier. So dia. Okay, yeah. So first I need to click here the new tool, and I need to mention the tool, which type of tool it is. So it is actually a hand mill tool. Please click. Please click. And this is also doing this side also. So this long edge, I'll select here hand mill, then OK. Then I have to write the name of the tool. I'll keep it same as 63 long edge. Okay. So I think it will confuse you. So I am going to load a new tool again by different name. Okay. Copy and mill. And mill long edge. Okay. Then we just fill other parameters like the length of the tool. So here we are going to provide the approximate length that will or like some other scale. So I'll be approximately measuring this tool because I need to provide the approximate values into the tool list. So I'm going to measure it with the help of this vernier caliper. So here I'm getting the length of around 170 mm. Okay, so this is the approximate length of the tool. So I'm going to put it here 170 in this column. Then I have to set the radius as well. So I'm also going to measure it with the help of this caliper, and it comes around 62 or 61. So I need to give the approximate values here in the table. So I'll be keeping it here as 62. After that, I need to mention the number of edges. So this tool has got 5 edges. So I'll enter here the value of 5. So what will we do? We simply then click here on the load icon, selecting this tool, and then we'll be loading it. So the tool will be loaded as per the location that we can also enter here, or this is the default location that the machine is providing to us. So we'll be loading this tool at pocket number 6. So I'll just click OK. Just a minute. Okay, so we'll be loading it. So the magazine is opened automatically. So here you can see, let's show the pocket number here. So here we have got pocket number 6. So machine automatically provided this pocket to us. So you can also see the arrow here. So this arrow shows that uh, shows points towards the tool that can be towards the pocket, where we can load or unload the tool. So we are going to load it in the pocket number 6. Okay, we have loaded this pocket number 6. Now, now we can just click OK here. Okay, now you can see here that the hand mill long edge tool which we have loaded onto the magazine is at pocket number 6. So now we have provided the approximate dimensions to the tool, like the length and the radius. Now we are going to measure it using the Bloom system. So our tool is at pocket number 6, and the length is 170 mm and the radius is 622 mm, which is all approximate values. So now we are going to measure this tool. And for that, we already have a Bloom cycle. So I have already written a program for that. That is actually the inbuilt cycle onto the machine. But we need to fix some parameters. We need to set some parameters here first. So we are going to measure help of this Bloom. We are going to measure length and radius of the tool. So this is the program that I have already written. So as I already said, a program is a combination of blocks, and the blocks are made from different boards. So here, this is the Bloom cycle actually, and it is the default cycle. Just we need to set some parameters here, like I have already set these parameters here. So I'm going to measure length and radius, and here it is also asking what are the points where this measurement needs to be done. Then we have other parameters as L offsets, R offsets. So these parameters need to be set. Also, we need to provide here some number of edges. So this time we have 5 edges. and this is also the number of times the measurement can be done. Then this is our repeatability, which tells whether the measurements, we are going to measure it 3 times, and then they will be compared. These values will be compared, and it is within the range. Then the machine will provide us the output. So I'm going to run this program now. So we'll execute it, and we'll see how. So here the very what we need to take care is we need to check whether the tool compensation length and radius is active or not. Once the program is started, so here you will see the tool length and radius values, and they should be there. So first, first we'll be doing it for casing tool. Okay, it is already selected. And we'll be doing it on the tool which we have loaded. Okay, so first we'll be doing it for casing tool, but still I need to change the number of edges. So for casing tool we have got 7 edges here. Okay. Okay, now what's going on? So the spindle is moving towards the location, towards the position where this tool clamp unclamp is going to run. So we have just clamped this casing tool. So now, so we have to take care of the tool length compensation and the radius compensation here. So that is the loan system. So it is going to measure the length as per our program, whether we are going to measure the length or radius. So this time we are going to measure both. So as per our program, it is going to give the values, the exact values of length and radius here. So you can see here. So this is actually the laser technology. So we have set it. So 3 times it will measure is. So this time the length is to be measured. So once the length is measured, then it will go for this radius. Now this time, now the radius is being measured. So this is the laser measurement of the tool, and which is quite accurate. Now the measurement is done, and automatically tool will move to its normal display. So now this time, so you can see here now. Here we have 0. So once I will reset this program, the values will be updated. Okay. So this tool is now having a radius of 31.634, and the length is 140.081 mm. So this is a casing tool. So we'll be performing this cycle for other tool which we have loaded, the longest tool, and we know for that we knew the values for length and radius. For length, I'll be showing it again, so that you will get confirmed that the values are being updated. So the length here is 170 mm and the radius here is 62 mm. So we are going to measure it now, and we'll see what are the exact dimensions for this tool. So here, I'm going to just change this tool here. I'm going to delete the earlier tool. I'm going to select a new tool. We are going to measure and mill long edge this tool. So I have to select it. I will just renumber it again. Okay. So this time our tool is anvil long edge. and the rest of the parameters are same because it's a similar tool which we have, and yeah, we just have to change here the number of edges. Okay, simply we'll run this program, we'll execute it. Okay, so I have just provided the approximate values for this tool. Now they will be updated automatically. So I'll be starting this program again.
Yeah.
Okay. So you can see here we have loaded this tool previously. Now we are going to measure this tool. So as per these moments are as per the cycle. Just a minute. I'll just switch the program now you want one room system to do this. Use it. Use this your in charge. Conclude. So I need to set actually some parameters here. So what we are going to do, I'll change it again. I need to set some parameters actually. But what will I do? I will just do it for the same tool. I'll do it for this facing tool again. So just remember it. Okay, I'm going to do it for facing tool again because the cycle is as per that particular tool. So here it will take some time if I'm going to do it for other tool. So that's why I'm going to do it for this tool. So again I'm moving to this facing tool. So here the length and the radius of the tool is 140.081 and 31. So what I'm going to do here, I'm just giving the approximate value. Say for example, I will type the length here as 138. Okay. And I will also write the radius as 29 mm, which is not true. So these are the approximate values which I need to enter here. Then what we are going to do, we are going to measure it again. I'll just execute this cycle. So here so once the program is executed, So we have just entered the approximate values for this tool. Now we are going to measure it again. So the length is measured 3
आप
times
देखो शेयर भी
and
नहीं हमारे
the
साथ
values are compared.
कर दिया अभी काम डन
Radius is within the range. Also the radius is going to be measured 3 times.
कितने मिनट तक का प्रोग्राम
So it is as per the cycle that we have set. The measurement is over. Okay.
मैं तो समझ रहा था 4
So
बजे
now
तक
you will see here the cycle is over. Now you can see here
5 बजे तक वैसे भी 12 लोग बचे हैं
these we have a radius of 0.00 and the length of 0. So once I will reset it, the value gets updated. Yes. Okay. So we have actually okay. So we have actually here set the values in the table. We have entered the length of 138 and the radius of 29. But here it is again measured and the length is now 140.081, the same which was previously, and the radius is 31.64. So these values are updated now. We can also see these values in the tool list. So here the length is also updated as 140.081 mm and the radius is 31.64. So this is the measuring system on this machine, which is very accurate because this is a high precision machine. We have got a very high accuracy, the high precision, because the least movement of the tool is 1 micron. So the measurement, so here any error in manual measurement of the tool is not acceptable. That's why we have got this bloom system installed on this machine. So we are actually measuring all the tools using this bloom system, like we I have showed you for these two tools. And I think it's all for today's session. Rest we are going to continue tomorrow, and tomorrow we'll be going first going to see the work offsets that we set on the workpiece as per our workpiece dimensions. So we'll continue tomorrow. So this is all for today. Thank you so much. Thank you everyone. Hope to see you tomorrow. Bye everyone. Should I continue or what?
You have time?
No, actually time is over.
You can continue. If you want, if you
start a new topic.
okay, fine. Hope like you had a wonderful session of the day with a basic introduction to 5-axis CNC machine. Thank you, Nadeem, for giving us a wonderful session. It was like for those who are not seen this machine, though we were not given the opportunity to see it offline, and most probably like we are always welcoming you to visit our campus and have view about the machine. Like you can interact with Nadeem, you can get too many things output over here. With this, we'll end up the day one session of for CNC module 1, and tomorrow morning sharp at 10 we'll start with day 2. The first session will be handled by Dr. Sajjan Kapil. It will be on tool path generation, how the model is being developed for in CNC machine. Thank you so much. We'll all meet on next day, tomorrow morning. Thank you.
और कितना ऊपर रखना है
Thank you so much, sir.